Okay, well, thanks for coming. Let's get started. So here's our agenda. I want to start off with a brief overview of what cloud encoding is, and then I will look at cloud encoding from two perspectives, on-demand and live, because they're two separate markets with two separate value propositions, and obviously two separate potential vendors. So when we think about cloud encoding, someone either builds their own encoding center and rents it to you, and encoding.com has their own encoding center as well as using several different cloud services, or they integrate with a cloud computer vendor and then sells the service to you. So basically it's encoding in the cloud, and the high-level benefits are lower capital expenditures, you don't have to buy the hardware, and elastic scalability. So and we'll look at a couple of different models on how scalability varies, but the theory of cloud encoding to a lot of people, and I think this is the classic cloud encoding schema, is if you have 1,000 files you need done tomorrow, you just send them up to the vendor and they should be able to encode those. You don't have to worry about how they provision machines, any of that stuff. Basically, it's just elastic scalability, I think, is one of the key value propositions of the cloud. It's important to know that there's a bunch of different ways you can get an encoder into the cloud. I mean, you can lease your own cloud machines and install your own server if that's what you want to do. You get the benefits of the lower CapEx, but you don't get the scalability unless you build that into your own little data center thing. The software as a service, I think, is the biggest category. This is the classic cloud encoding type service where you go direct to encoding.com or to Encoder, or you can go via Amazon, which you can use for Telestream Vantage or now Harmonic Pro Media Carbon Coder, and you just deal with them on a per gigabyte or a per second or per minute basis in terms of encoding. So that's software as a service. And platform as a service is Elemental, where you basically buy a certain number of machines for each period. So you say, I want 12 GPUs available to me for this month, and then you pay them based upon the machines that you rent. And we'll look at what the differences are. If you want to roll your own, do it completely yourself. So you go out and buy the cloud encoding service, you provision it, you install the software, and then you maintain it. The benefits of that is you have the dedicated resources. So you basically, know what you're getting. You say, I'm leasing 10 cloud computers. They're mine. When I want them, I can get to them. I can turn them off when I don't want to use them. And you don't have to buy the hardware. So you get the lower CapEx cost and you get the benefit of working in the cloud. The negative is, if you decide to do it yourself, is that you have to run everything and you have to buy the software. So this is technically cloud encoding because you're encoding in the cloud, but very few people are doing this. Again, the classical model is software as a service. So you basically go to a Encoder or an encoding.com and you say, I'm just going to upload my files to you. You charge me based on minutes or gigabytes, however you want to do it. And you take care of the installation, you take care of provisioning all the cloud units, you take care of pretty much everything. I just encode my files, choose my presets, and then you deliver them to me at some cost. So the benefits are, it's very simple, you're doing very little work. You're choosing the presets, uploading the files, and they do all the stuff behind the scenes to deliver the scalability and to deliver the encoding. The negatives are, and this is what Elemental would tell you what's wrong with the software as a service. You don't have dedicated resources. So when you upload a file to encoding.com, you don't have a guaranteed cloud encoder waiting for you. Now, they're very fast, they're very capable, they have very big clients, they do everything very quickly, but they don't have resources dedicated to you. So if you're CNN and you need a file encoded in 2 minutes, while there are service level guarantees, you don't have dedicated machines waiting for your upload. So I don't think it's a big knock against the software as a service people, but this is what Elemental would tell you is the negative of that approach. In Elemental, is obviously the platform as a service, where you reserve and pay for dedicated resources. It's almost like a private cloud. So these are your machines. Nobody else can use them. They're totally secure. If you need a file encoded, as soon as it gets up there, you're guaranteed to have that encoding start. And that's the fundamental difference between the platform as a service, which is Elemental, and the software as a service, which is Encoder and encoding.com. Okay, for the people who came in late, the handout that I'll be speaking from is available on my website, which is the Streaming Learning Center, and it is the top article on the upper left here. So it's streaminglearningcenter.com. Click over there, click Choosing the Cloud Encoder, and you'll be taken to a page where you can see Choosing Cloud Encoder.pdf. Click that and you can download it. Okay, so this is, again, the platform as a service. The pros are the resources are always yours. You know, as soon as you need it, it's guaranteed to be there. The negatives are that it's more expensive at the lower end. You don't get this for $10 a month. You get this for $3,000 a month. And then we'll look at how the costs compare a little bit later, but it's more expensive buy-in, and you have to worry about things like, well, do we want to save money by shutting off some of these instances, or do we want top performance by keeping them running all the time? So you have some of the administrative burden that you don't get with the pure software as a service vendors. Okay, and then for people who don't know how cloud encoding works, it works pretty much just like YouTube. You know, you upload a file, you choose your encoding profiles, and then you start encoding. If you've used YouTube, then you've used a cloud encoder. And most of the larger customers for all these vendors use the API as opposed to the user interface. And we'll look at, you know, not all services offer a user interface because 99% of the customers they really want, all the high volume customers, are going to use the API anyway. And then the biggest negative traditionally for cloud encoding traditionally has been the upload time for local files. We'll look at how that paradigm has changed over the last few years in a moment. And that was traditionally reduced by upload accelerator tools like Aspera. So the biggest negative, you know, why did it take so long for cloud encoding to really take off from a VOD perspective? Because we were using very, very high bandwidth mezzanine files, and it took a long time to upload them. And nobody wanted to wait, you know, 3 hours to upload a file to start encoding. Okay, so that's kind of an overview of what cloud encoding is. And now let's look at, you know, 3 types of companies. Who should go exclusively to the cloud? You know, who should go to the cloud, go directly to the cloud, do not pass code, do not collect $100. There's a class of companies that should do that. There's a class of companies who should really consider staying on premise, and then there's a class of companies who should augment their on-premise capabilities by going to the cloud. So the companies I think that really should even not consider encoding on-premise are companies that receive a bulk of videos from third-party sources. So the upload lag isn't a factor. You know, people are uploading files to them. They deliver from the cloud. They either send the encoded files to a CDN or to Amazon to act as a CDN. So they're delivering from the cloud. The files have to get up to the cloud anyway. And video encoding isn't their core business. It's kind of ancillary. And you know, the changing math of cloud encoding, back in 2009, when cloud encoding first came on the scene, you had a 30 megabit per second mezzanine file to produce one file that you distributed via flash on your website. So you'd upload a 30 megabit per second file to the cloud, and then you'd get back a 600 kilobit per second file to put on your website. This is pre-mobile, pre-OTT, pre-adaptive. So you know, that was kind of the math back then. Now, you upload one 30 megabit per second mezzanine file to produce, in the test group we'll be looking at later in the session, 24 distribution files, you know, 12 for flash, 12 for iOS. And the total bandwidth of those files is around 70 megabits per second. So you're actually saving time if you upload to the cloud and encode there than if you encode on-premise and try and upload from there. So this is one of the biggest reasons why on-demand cloud encoding really starts to make a whole lot of sense. Because in 2009, we were producing one file for distribution, and now we're producing many, many files for distribution, and it takes longer to upload them than it takes to upload the mezzanine file. And some examples of the companies that, I looked at 3 parameters, companies that should go directly to the cloud, get the bulk of their videos from third-party sources, deliver from the cloud, and video encoding isn't their core business. And I just finished an article for Streaming Media. It'll appear probably in the July issue. And 3 of the companies that I spoke to were FieldLens, which is a collaborative tool for construction industry. So if you're managing a construction project, you can use their website to manage it and then communicate with all your suppliers and your customers and your vendors. And what videos do is they document the status. So if I finish this room, I could take a video of this room, upload it. Everybody looks at the video and says it's fine. So all the videos were uploaded. They're not created on-premise, so there's no upload lag. They're delivered from the cloud. And video is not their core business. They don't need to be really good at video. They just need to use video. So it's a perfect example of an application where they should never have considered encoding on-premise, and they never did. They went directly to the cloud. Unruly Marketing is a video marketing company that helps companies promote their videos. Again, all the videos were uploaded to them. They're delivered from the cloud. And although they're a video-related company, video production and distribution isn't their business. So, again, it's ancillary to their core business. It doesn't make sense to invest a lot of resources in it. And DotSub is a company that provides caption and translation services. You upload your files to them. They encode it so they can send it out to translators and captioners. And again, they meet the 3 requirements. They went directly to the cloud, should never have considered on-premise and never did. So that's the class of companies who should go directly to the cloud. The companies who should stay on-premise are companies who have fixed and consistent encoding needs. So if you're a network, you produce 30 shows a week, you're never going to produce 50, there's never going to be a burst requirement. You probably have on-premise encoders now. You paid $20,000 a unit for them 2 years ago. They're still doing fine. There's no reason to go to the cloud. Because if you encode consistently, you're going to pay a lot less if you just buy the hardware and encode it yourself. And we're going to look at the project we're going to talk about later in the session involved 10 files about 50 minutes long, which I encoded to 24 presets. And each time I did that on Amazon, it was around $270. So if you do that twice a week, for 52 weeks a year, you're looking at $28,000 a year for Amazon. Now you can buy an elemental transcoder for around $20,000. So if you throw all the service and support and the electricity and all that stuff into it, you're probably at break even after a year, and then that computer will encode for you for 2 or 3 years longer. And it's software upgradable, and you're not going to lose out with new formats. So if you're doing a lot of consistent encoding and you're a media company, it really makes sense to consider staying on premise. Now, in the cloud story that I produced, that I referenced a moment ago, there were several companies that kind of fit this model that decided to go up into the cloud. They said, we don't want to buy the hardware. We don't want to expend the CapEx. We don't want the maintenance costs. We don't want to mess with it. Our business is, we're a broadcast network. We're not an encoding company. So we don't want to mess with it. We want to go directly to the cloud. And Univision is a big Spanish broadcasting network in the United States, and they went totally into the cloud. They have some encoders that do on-premise functions, but all of the distribution encoding, all of the encoding for Flash or for HLS or for HDS is done in the cloud. So they have an Envato capture card at the video router, which captures the cable broadcast, converts that to a mezzanine format, and uploads that to the cloud for encoding. And then if they get a ProRes or an Avid DNX HD file from a broadcast partner, that's encoded to the mezzanine format on premise and then set up to the cloud. So no distribution encoding in-house, even though they meet the requirement I said before, where they've got pretty predictable demand for encoding needs. So I think it makes economic sense to buy your own encoding hardware if you've got fixed encoding requirements that are very, very consistent. But some companies are saying, we don't want to be in that business. We don't want to spend the money. We want to go directly to the cloud, even though it may not be economically as inexpensive. And who should augment with the cloud? Companies with fixed encoding capabilities, but also have burst requirements. They have some needs for very, very short but high volume encodes that they really can't perform with their in-house equipment. And Scripps Network is one of the companies I spoke with when writing this article. They've got a bunch of very, very well-known cable brands, including the Food Network, Cooking Channel, Travel Channel. So they have consistent encoding needs plus burst needs. So when the iPad came out, they had a bunch of rack encoders on premise, but they couldn't get to the iPad encodes. They needed to encode their entire library for the iPad. They couldn't do that, so they, rather than buying a bunch of machines for 2 weeks, they went up to the cloud. So any company with fixed requirements, but also burst requirements, should consider cloud encoding to augment that, and we'll talk about how to do that in a second. And then another company I spoke to is T3 Media, which provides content management. It's the biggest encoding company I'd never heard of before. They're encoding 10,000 plus files a day for a lot of Hollywood clients, a lot of broadcast clients who need video management services. And they went to the cloud, again, for burst requirements. So they had some housekeeping encodes they couldn't build to a client just to update their own internal video files to newer standards. 600,000 of them that they kept putting off because they couldn't dedicate their own resources to it. So they took that to the cloud. That worked very well. And then they have some clients who have very erratic demands. So they have a, they have a show that's based on UGC video. Videos uploaded to the show. Some days it's 2,000 videos. Some days it's 24 videos. So you really can't buy internal hardware to service that demand because you end up buying for 2,000. And then it goes underutilized most of the time. And then if you decide that you want to obtain burst capabilities, what's the best way to do it? The easiest way to do it seems to be to use a cloud service that's supplied by the supplier of your on-premise hardware. So if you're using Elemental, if you're using Telestream, if you're using Harmonic, check out their cloud offering. Why? You get two things. You get the ability to use the same presets, which is huge because your presets work. And if you look to another cloud vendor, you have to create additional presets, and then you've got to go through all the debugging efforts to make those work that you went through with your initial presets. So if you can use your presets, it's a big win. And the other big win is you can control all the jobs from the same interface. So if you're using Elemental Encoder, you can control jobs both on-premise and in the cloud from the same UI. Very simple, very polished, very easy to do. All that said, the two companies I spoke to when I wrote this article didn't do that. They both used Zencoder. Scripps also uses encoding.com, even though they've got, neither one of those companies supplies any kind of on-premise encoding capability. So, a sample of two doesn't disprove what I said the previous slide, but it's interesting that neither one of them chose an on-premise vendor for their cloud capabilities. And what I also found interesting was initially both companies used the cloud for very, very specific jobs. So in the case of T3 Media, they said if the file is under 3 minutes, so it's under a certain file size, we're going to send it to the cloud. If it's longer, we'll encode it in-house. And both companies reconfigured their infrastructure later so they could do any job anywhere. They're platform agnostic as to where they actually encode their jobs. And Scripps told me they can upload a 45-minute mezzanine file, which could be 6 to 10 gigabytes in seconds. So they've just got very, very high bandwidth to the cloud, and they don't even consider upload time a factor when they decide where to actually encode the file. So I think that's the best attitude to take if you're going to augment your encoding with cloud services. And a lot of that goes back to the slide we looked at before, where it's actually more efficient to upload and encode there from an upload standpoint. You're going to upload one 30 megabit per second file as opposed to 70 megabit per second. 70 megabits per second for a file that you encode and then distribute from the cloud. Okay, so how do you choose an on-demand cloud encoder? This is kind of the framework. We'll look at these one by one. I mean, the first thing I would look at is, again, integration with your existing on-premise hardware. I think it's a simple win-win if you can provision from the cloud from your current on-premise encoding vendor. The second requirement is, can it get the job done? Can it do the work that you need it to do? And there we'll look at, can it retrieve from and deliver to the places your files live and where you need to deliver them? Do the cloud vendors support the format? And does it support the interface paradigm that you need to produce? And then once you meet those basic requirements, what's the best option for you? And here we'll look at quality, performance, service level agreement, and the cost and pricing model. So again, if you're augmenting your existing capabilities, I think the easiest way to do it is to choose the cloud, choose the hardware vendor that you're currently using and see if they have cloud services. And at this point, most of them do. The ones I'm most familiar with are Elemental. Harmonic just went up to the cloud with ProMedia Carbon MP. Telestream is in the cloud with Vantage. And Saracen Squeeze has a cloud service as well. So if I'm using any of these vendors as my on-premise encoder, I'm going to look to these cloud services and at least see if that's the best offering for me. Again, it may not be the best possible solution, but it's something that you need to consider. Okay, and then we transition to, can the cloud vendor get the job done? And you're going to hear me, the big exception to a lot of these is going to be Amazon Elastic Encoding. Actually, it's Elastic Transcoding, excuse me, because it's the least flexible service. So Elastic Transcoding has a very nice pricing model, but it can only retrieve files from an S3 bucket, and it can only deliver files to an S3 bucket. So it's very, very limited in terms of what it can do from a retrieval and delivery standpoint. And then once you're looking at retrieval, if your service can retrieve from your desktop, from FTP, a bunch of different sources, does it offer any kind of acceleration? And most of the bigger ones do. And then delivery obviously needs to be as extensive as the input. Can it deliver to all the places where you need your files to go, including, I guess CDNs aren't up here. It needs to be able to deliver to your CDN. Most other than Amazon can. And are there even syndication integrations? Can it deliver files to you or integrate with other services that you may need for your delivery needs? And then format support is a big one. Again, Amazon still doesn't support ProRes. That's pretty fundamental for very many video producers. Most of the other cloud services offer much broader file format support, but if you're using exotic formats, whether it's RED or RE or any of the camera formats, you need to check that because not all of the cloud services support those at this time. And then you've got a bunch of output requirements. You've got single file requirements. A lot of services support H.264 and WebM. I'm sure they'll all start supporting HEVC in the near term. Very, very little HEVC support at this time. Adaptive formats, again, the only adaptive format that Amazon currently supports is HLS. So if you need HDS or Smooth or any kind of dash format, you can't get that from the Amazon Elastic Transcoder. The Elastic Transcoder doesn't offer any caption-related capabilities, so if you need closed captioning support, you can't get that for them. And they also don't offer DRM. So the more that you have exotic requirements, the more you have to investigate this up front to make sure that the cloud encoding vendor can support them. And then I think 99% of the big clients are going to use the API for cloud encoding, but if you're If you're a low volume client, you don't want to use the API, you want to use the UI, you need to make sure that the vendor that you're talking to supports a UI. Encoder doesn't have a UI. That's probably the main one. I think Haywatch also. Anybody use Haywatch? I don't think they have a UI either. So, and then in terms of how good is the UI, Amazon has a UI, but there's pretty dramatic deficits. I gave it a 3 out of 5 rating in a review that should post in the next few days on Streaming Media website. You can't edit a preset. Very frustrating. If you want to change the data rate from 600 kilobits per second to 700, you have to create a new preset based on the old preset, and it's just messy. It's not very usable. Probably more important is you can't save a job. So if you want to upload one file and encode to 8 different outputs, you can't save those 8 outputs as a job you can reuse. You have to enter that pretty much every time you want to encode it, and that's very frustrating as well. Encoder doesn't offer a user interface. Encoding.com has a user interface, but there's no preset bin. So again, if you want to change that preset from 600 to 700 kilobits per second, there's really no easy way to do it. You have to create an encoding job, choose the existing preset, change the data rate, save it as another preset. So now you've got 6 presets that are kind of all the same because you can't delete presets anywhere. So it's very frustrating to use, and they also don't have any jobs function. So if you want to, everybody is encoding a single file to multiple outputs at this point, and with encoding.com, you can't save those multiple outputs as a job you can reuse. And then Elemental probably has the most fully featured UI that I've seen. Why? Because they started as an appliance, and appliances all had very, very full-featured UIs developed over the last 5 or 10 years. So if you're buying based upon UI, which I think very few people are because they're all API based, Elemental would be the obvious choice. And this is kind of where things get interesting. I spent the last 2 weeks testing video quality, and what you do when you test is you're very anxious to see dramatic differences. Don't use them, they're awful. Use these guys, they're wonderful. And all these companies are pretty mature at this point. They've been around for a number of years. A lot of them use X.264. So it's just a question of how quickly can they use X.264 to produce the output. So there's very little variability of the quality, right? So Amazon.com offers single pass encoding only. So all the other vendors say, well, their quality's awful because they're single pass only. So I ran my tests through Amazon, Elemental, Encoding.com, Quickfire, which is a company in beta, very startling performance results, we'll look at it in a second, and Encoder, and I found that, Amazon was slightly behind, but nothing you'd ever notice unless you really did a side-by-side comparison, and the rest were virtually identical. And I just want to point out the quality comparisons that I did. Let me jump to this chart here. This is the adaptive group of presets that I used to test from a performance and a quality perspective. And what I did when I compared quality was compare this file here. So this was the most aggressive full frame rate encode in the adaptive group. Right, I didn't want to compare quality here because everybody looks good at 1080p at 7 megabits per second. So I said, let's compare the quality here because that's the most aggressive encode in the adaptive group. And I also tested and compared at 720p, 800 kilobits per second, which is much more aggressive. And I also saw very little quality differences there. So, and let's look at a couple of those. So this is 640 by 360. And again, this is why I want you to know that you can download the handout now because it's pretty dark. This is one of the most aggressive frames in this test file I've been using for the last 5 years. This is a ballerina panning across the stage. There's a lot of detail here in the window and the curtain. And you can see that up on the Amazon window, there's a little bit less detail in the window here, then you can see up here, then you can see here, here, and here. So when I talk about very little difference in quality, that's what I'm talking about. If you didn't see these side by side, you wouldn't look at this and say, this is awful, this is great. You really wouldn't notice the difference. Here's another frame, particularly relevant. This guy's got a fine pinstripe shirt, and again, I'm not sure how much of this is caused by the projection, but in some lower quality encodes, you can see less detail here, but that's the kind of thing I'm talking about. Now, so here's where you can download the handout, and you can check out the frame comparisons we're seeing in the presentation. Once I go back to my room after this presentation, I will upload both the comparison frames so you can view them online and the source files themselves. So you can download those. Didn't get those up before I came here today, but if you go back to streaminglearningcenter.com tonight, you can actually download the 640 by 360 files produced by the various services I looked at and run your own comparisons. Okay, so here's comp 2, here's comp 3, and again, this is a very high motion ballet sequence, and I'm seeing very, very little quality difference between any of the services. So the bottom line from a quality perspective is many of the cloud encoders use X.264, as I said. The others that use their own codecs have been in business for a while. They've been competing with X.264. So all the companies are reputable, despite the claims of superior quality. I just don't see that much difference. I would not choose a vendor based upon output quality. I think they're all very good. They're all very similar. And then here's where I was going to put the resources I just told you about. And let's talk about performance. I used 2 different test cases. So we had 10 around 50-minute test files that I encoded to 24 different output presets. So the 24 output presets were, this is 12, and I took these to MP4 files so you could deliver to Flash via RTMP dynamic streaming. So it was 12 MP4 files, and then 12 groups of files for HLS delivery. So the really good, or I don't want to say really good, really bad, but some of the encoding tools like Encoder, first they would take this adaptive group and create the MP4 file, and then they would, instead of re-encoding it again to create the HLS files, they would transmux the MP4 file into HLS files and create the manifest files as well. So at the end of the day, and this is important for our pricing discussion, there were 24 files created, 12 MP4 files, and then the MPEG-2 transport streams necessary for HLS delivery. Why is it important that 24 were created? Obviously it takes time, but also because encoding.com charges for delivery. So they charge based on delivery bandwidth. So if you create 24 groups of files or 24 files, you're going to pay twice as much as you would for a vendor who's doing it based on seconds. And let me go. Okay, so I ran 2 tests. One is kind of the 50-minute broadcast network show. You've got a very, very long show, very demanding test. The other one is you've got commercials that you want to encode. They're all 30 seconds long. It's more an administrative thing. How quickly can they get 50 files in, encode them, and get 50 files out? So 2 very different tests. Here's the presets again. Now, the implementations varied, and this is not so important for the 10, some of these vendors I had to load the tests by hand, so I had to copy and paste XML in. So for 10 tests, that might have taken 3 or 4 minutes. But if it's a 3-hour encoding time, you don't really care, right? It's not going to vary the results one way or the other. With Encoder, let me just go to them. With Encoder, I had to do manual copy and paste, which wasn't a big deal again for the 10 files, but when you're looking at 50 files, all of a sudden you're taking 6 or 7 minutes as compared to Elemental set things up for me very nicely where I just pressed the button and everything started encoding. And Quickfire did the same thing. So we'll look at how those may have affected the results. And here are the results. So this is the 10 approximately 50-minute files. Here's Amazon. The overall encoding time for Amazon was 4 hours and 37 minutes, which was by far the longest, which was pretty shocking, right? Because they own the system. But there was, and this is like from when I pressed the button to when the last file was done. So, and you would see that Amazon really didn't start encoding some of the later files for a much longer period. So there was a long queue time within the Amazon system. They took 4 hours and 37 minutes. Encoder was about the fastest in the currently shipping group. They produced the 10 files in 1 hour and 48 minutes. And, again, 4 minutes input time. And the 50, 30-second files, they were very fast, but I couldn't really put the files in quick enough to support their encoding efforts. I mean, they were doing the files, I think if I had dropped all these files in at once, like I did with Quickfire and like I did with Elemental, this encoding time might have been, 4 minutes. I think this is an instance where I really slowed them down. Encoding.com, not significantly difference between the 148 and the 153, about a 4-minute entry time here, and about a 2-minute entry time here. So Encoder was a lot more efficient with the 50, 30-second files than Elemental was. I'm sorry, than Encoding.com was. Elemental took about 3 hours, very slow result for them. They thought they should have been faster. They're looking at that. That may change over time, but this is how it played out. And they performed much better in the 50, 30-second files, producing that in 1922, which is very competitive against Encoding.com. And then Quickfire is a beta system that I reviewed under non-disclosure. I ran the same exact tests as I did with everybody else in pretty much the same way. Again, they set things up so that it was a very efficient input time for both tests here, and their results were quite startling. So they produced this group of files in 23 minutes, and this group of files in 441, dramatically faster than any other vendor. And I checked the quality, and the quality was pretty much identical to everybody else. So it's a system in beta, and I don't know when it's going to be. I think they're going into private beta. There's a gentleman here in the back of the room. Craig, raise your hand if you want to talk to him about the system. He's from the company. So I tested it. I'm comfortable in my results, but it is a beta product. The features are undisclosed at this point. I was able to produce H.264 files and HLS files, but can't say anything about DRM, captioning, any of the other stuff. But we did produce the files and compare the quality, and the results appear as they appear. So performance conclusions. Quickfire is a very interesting technology, but it's still, I think, pre-beta at this point. So if who cares about performance that fast? Probably 95% of the companies out there don't. It's like, let me upload a file today, and as long as I get it by tomorrow, I'm fine. But if you're a news organization, you've got very, very high volume requirements, then the ability to cut your encoding times to the degree that we saw was very, very, or could be very, very significant. Amazon is okay for companies where encoding time isn't important, and I think, again, that's probably 95% of the companies. They don't have a service level agreement, so if time is of the essence to any degree, you've got to really watch what you're doing if Amazon is your choice. Encoder, encoding.com, very, very close in the longer files. Encoder was a lot quicker in the shorter files. If that's the type of files that you're looking at, that's a significant difference. And then Elemental, as I said, they were surprisingly slow, and they're looking at the results and seeing. I tested this about 1.5 years ago, and the results were much closer between the big three. So they're trying to figure out, well, what happened? Why did we drop back so much? So that may kind of change. Okay, and then there's lost Amazon here. And then there's what you pay for it. Amazon charges by the minute. The prices vary per region. In my region, which is North America, East Coast, it's $1.50 per SD encode and 3 cents a minute for HD. So that's going to vary around the world. That's just a representative price. Zencoder is price per minute. It varies based upon commitment, ranging from 1.5 cents a minute to 5 cents a minute, and that's for SD. HD is twice as much. So if you're in the lowest quantity tier, you're paying 10 cents a minute for HD encodes. The thing that's nice about Zencoder is if they're transmuxing, they're only charging 25% of standard pricing. So they're going to charge you 10 cents a minute to create the initial MP4 file, but if you transmux that, then they're only going to charge you 2.5 cents for that HD transmux. It complicates things, but it's a nice benefit. Encoding.com and Haywatch, they charge you on a cost per gigabyte basis, and Elemental charges you based upon the CPUs that you provision and then how much you keep them running. And then in some of the other services that are pricing through Amazon, they're provisioned from Amazon, and there's usually I think ProMedia Carbon was like $70 a month plus machine time. So you're going to have to check and look at their pricings there. And coming up with we're going to look at a pricing comparison. It's very beta. Usually when I show something like this, I check it out with the vendors first because, I usually miss something when math is involved. Obviously, the price per minute is the simplest. If you got a 30-minute show to 24 formats, you have the ability to pretty much calculate what your price is going to be. The price per gigabyte can be simple if your inputs are the same. If you're always inputting a 30 megabit per second MES file, you can calculate it pretty easily. Some of the vendors I spoke with who were choosing cloud vendors said, sometimes we're uploading ProRes, sometimes it's MP4, sometimes it's RED. It was very difficult for us to come up with comparative pricing for a cost per gigabyte system because our inputs always varied. So that can be complicated. Elemental, or encoding.com, if you use twin turbo mode, which is a mode that I use for all my encodes, that adds, I think, 2 cents a gigabyte. So you've got to factor that in. And encoding time for Elemental is going to vary based upon whether or not instances were spinning. So with Elemental, you've got 10 machines that you have access to. That's the plan that you bought. If you have them all not running, and then you load 10 jobs into the system, it's going to take 5 minutes for those to start to spin up. So that's going to add time to the Elemental encodes, and that wasn't a factor in these tests. They were spinning when they uploaded them. So let me just go right to the pricing comparisons. Okay, I messed this up. So what I tried to do here was I tried to figure out how much it cost to produce the one big job. So the 10 50-minute files to 24 outputs. So this one is pretty simple because Amazon has a very simple pricing model. So this number is correct. This number was verified with Zencoder, so this number is correct. This number was not verified with encoding.com, so this probably will change. What I used here was their lowest published price, but they say you can get a cheaper price if you have a higher commitment. So I'm pretty sure this number will change dramatically, perhaps even as much as 50%. I will verify with the company today, and I'll get that up in the final PowerPoint PDF by say tomorrow. So if you're worried about pricing, check back tomorrow, and then I'll do the same with Elemental. Although Elemental kind of supplied the template for this kind of price comparison. So with Amazon, it's basically cost per minute. It scales pretty linearly or precisely linearly. Same thing with Encoder. With encoding.com, you pay a minimum for the month, and you pay a fee above that. So these are pretty linear, but not exactly linear, because you get 10,000 free minutes or 100,000 minutes in this plan, and that affects the price. But my calculation was, for 1 in a month was $858, for 10, $66.10, for 100, and this is all within a month period, the total price is going to be $64,000. Now again, this is within a month because this is monthly pricing. Elemental, you're spending a minimum of $29.95 to get 125 hours encoding time. If you do one job, it's going to be $29.95. Didn't take all those 125 minutes. If you do 10 jobs, it's going to be $48.10. If you do 100 jobs, it's going to be $33,500. So again, not, you want to check with the vendors before I say these are final, but I think the prices are going to be close. Elemental's point is, you're going to pay a significant chunk up front, but you're going to make it up in volume if you have a high volume, because you're paying for machine time, just not linear per gigabyte or linear per second. Any questions on this? Okay, so if you're choosing a vendor on the VOD side, I think you look at architectural factors first. Can it integrate with my system? I think the presets and the single command and control interface, I think that's really useful. Then you got to make sure it can do what you need it to do, retrieve the files from your current data stores, send it to where you want it to send it to. Then you look at interface, performance, and pricing, and that's how you make your decision. Any questions on VOD?
What is the platform for Fire?
Say it again?
What is the platform Fire is running on? Is it Amazon?
It's cloud. You can talk to Craig. He's going to, it was kind of a black box to me. It was like, press this button, check the output files to make sure they're all there and they're properly configured, but it was a black box from my perspective.
You didn't mention at all security. Is it a security factor in order to choose a cloud encoder or not?
So is security a factor to choosing cloud encoder? I think it depends on who you ask. I think one of the, both on the client side and the vendor side. So Elemental will say that if you get those 10 machine units from us, it's totally secure. Nobody else's data will go through that. It's firewalled off. It's basically your stuff. On the other hand, encoding.com and Encoder have a lot of broadcast clients that are very concerned with security. So I think they would say, well, ask our clients, because they're more concerned than anybody, and they're our clients. So they don't think there's a huge difference between a software as a service and a platform as a service.
Is the security level almost the same for the cloud provider?
There's no real way to test that like you can with performance. I'm not a hacker. I didn't try and but I think the perception is that yes, they're all equally secure, because companies with very high stakes video, are using all both types of vendors.
Can you talk a little bit about SLAs? So, because the cloud providers will have SLAs, the public cloud providers, so the encoders will have SLAs, the public cloud providers will have SLAs sometimes. But how does that then get underpinned? So, if you're an encoder and you're running on a public cloud platform, presumably your SLA is reliant on theirs.
Okay, good. So the question is, how do the, if you've cloud storage SLAs and then cloud encoding SLAs, what happens if the cloud, I guess the cloud storage SLA screws up and your encoding gets hosed? I don't know the answer to that. I haven't studied that. I tend to think that SLAs they're more to protect the company than they are to protect the client, because it's more a limitation of liability. If you're encoding the Super Bowl and you need to get, one of the soccer matches, and you need to get the highlights within 2 minutes, and your cloud encoding vendor goes down for those 2 minutes, it's more a limitation of liability. You can't sue them for for hundreds of thousands of dollars because you lost some advertising. All you can do is ask for 2 minutes worth of the monthly commitment back from them. So I tend to think that's more of a, something they put out to make people feel good and to limit their own liability, and it's not a real value to the customer. And also, I should say at the other side, I don't think they come into play a lot. I think these are all pretty reputable services who deliver 99.9% of the time, and but obviously it's important to you, but I don't have that level of knowledge within each of the SLAs.
George Boat, Chemistry. I'm interested in the performance comparisons. Do these services declare how many different machines are being spun up to make those performance comparisons? Clearly, if it's one machine, it's a very different result than 100 machines.
Very good question. So, do the vendors tell you how many machines are spun up? The answer is that the platform as a service vendors do, so you can track that with encoding, with Elemental, but with the companies, with Amazon you can't, with encoding.com you can, and with Encoder you can't. But really, you don't really want to. It's a pure software as a service. You just want to upload your files, and look, your job is to get it to me as quickly as possible. I don't want to know those details. I don't care about them. So, on the other hand, the platform as a vendor, guys, Elemental, you control that. So that's the only one where you really know.
I've got a question about development of the companies in terms of R&D and codecs and moving forward. Do you have a view of, say, working with Elemental gets you better R&D and HEVC support and things like that? What's your view across the board of those four?
So what's, I think they're all very reputable. Elemental develops their own codecs because they're doing a lot of GPU stuff. That puts a little bit more of a development burden on them as compared to the others because Encoder and encoding.com are, they're relying on like X.264. So they've got their codecs delivered to them. Less flexibility, but they're not, and I think they're going to use X.265, where Elemental is creating their own codec. So it's a little bit more work for Elemental, but I think they've proven their ability to deliver over time, both quality-wise and performance-wise. So I think these are all very, very reputable companies who will be around for a long time, and I think they're all equally good at that. Okay, let me go on to live VOD. Not live VOD. Let me go on to live cloud. I think this, obviously, it's a much shorter topic. So we'll cover the workflow, the key benefits, use cases, then some of the business models. So live cloud transcoding, here's my trusty and obsolete XHA1, and we've got a Teradek encoder here. So if we were filming this and transcoding this, we would send a single high-quality stream, maybe 720p at 4 megabits, into the cloud for a real-time transcode, and then the transcoder would transcode that into 5 files for Flash and 5 files for HLS. So cloud transcoding, that's what it looks like. The reason I really think this is, I think this should have taken off faster than, I saw why VOD encoding didn't take off in the cloud because of the whole upload thing, but this is one that you don't have the upload delay lag because, it's all live, and you've got lower CapEx and greater scalability, and it costs you less on site because you don't need a big encoder that can encode the 10 streams that we looked at a moment ago. So I think live cloud transcoding is a huge market about to happen. Key benefits again, less money up front and less outbound bandwidth. And anybody who's produced live events in a non-studio setting knows this is always a problem. So to get, this single stream out, you can do on a 6 or 7 megabit per second connection. To get these 10 streams out, you'd probably need a 20 megabit per second connection, which is a lot more expensive and a lot harder to provision. So, and also, if you wanted to produce these 10 streams on site, you need a $20,000 piece of equipment here. So live cloud transcoding turns the $20,000 encoder into a $500 encoder, and then really reduces the bandwidth here that's needed to produce those files. Both very relevant to me because I do a lot of live event production. The use cases, if you're doing infrequent events, if you've got one event a month, then live cloud transcoding makes a whole lot more sense from a CapEx standpoint because you don't want to spend $10,000 or $20,000 on an encoder if you can spend $150 to do live cloud transcoding for that 1 hour. And then if you're broadcasting from sites with limited, if we were broadcasting from here, we're going to have limited outbound bandwidth. Live cloud transcoding is a much better solution. If you've got a studio, you probably have the bandwidth you need because you've always had the bandwidth you need, so it's not a big differentiator there. There's two ways to get live cloud transcoding. You can buy your own. The best known solution there is the Wowza transcoder. You put that in the cloud, send your streams to that, and that will encode, transmux, and deliver the files for you. Or you can use a software as a service model, and that's Encoder is one of the few standalone vendors out there today where you can send a stream to them, and then they will, do all the work for you in terms of transcode, transmux, and then send that to your CDN for delivery. And their live transcoding is also available as an integrated service or more comprehensive product. So HeyVision, iStream Planet all have live cloud transcoding functions, but they're only available within their own internal product. So if you want to use the iStream Planet Aventis platform, you get live transcoding, but you have to use their whole platform. You can't send it to your own player, send it to your own CDN. And same thing with HeyVision. HeyVision started out having allowed a live cloud transcoding service, but they folded it into their own operation, and it's not offered separately. As far as I know at this point, Encoder is one of the few, if not the only, vendor who is offering live cloud transcoding as a service that's not tied into other parts of the platform. You can get it by using Brightcove Live, but you can also get it independently if you want to provision it that way. And then, this makes it pretty simple to choose. If you want to roll your own, Wowza is the obvious choice. You buy the Wowza server, or you lease the Wowza server, you buy the transcoder, and then you can put it where you want it, whether it's on-prem or in the cloud. And then if you're looking for a third-party service provider, Encoder is the obvious choice because they may be the only one. I know there's another vendor who used to do it. They were bought by Wowza, and that product is off the market. But these are the two directions I would go in. And then if you want a service provider, then YouTube Live has it, Brightcove has it with their platform, iStream Planet has it, and HeyVision has it. Any questions on live?
Just on the content protection, is it only for an unencrypted use case that you have live? So how do you encrypt it?
Good question. My impression is that I don't know the answer. So email me the question but I think it's available on all the platforms, but I'm just thinking I don't know that. So I'll let you know.
It's Paolo Valenciano from CTN Communications. You said that the live encoding, cloud encoding market will become crowded very soon. What do you know?
What do I know?
What insider knowledge do you have?
I don't. I don't have any. I just think I think the value proposition is more striking. I think if you talk to the cloud vendors as I did on the VOD side, what's your biggest competition? Their biggest competition today is people still doing it on premise. So it's people who haven't bought into the whole cloud transcoding proposition. On the live side, the benefits are so clear that any live event producer would say, yeah, I want that, and would transition to that very quickly. On the other hand, if you talk to Encoder, it's still a very small percentage of their business. So I guess I'm a little bit surprised that it's not taking off quicker. But in the last 12 months, iStream Planet announced their internal solution. HeyVision brought theirs in-house. There's just been, there's just been a lot more activity than in any other segment of the market. But I don't know anybody about to come off. YouTube Live does a great job with it. So I think it's such a clear value proposition that it's going to be the way everybody does it in 3 or 4 years, whereas I think the cloud transcoding will be a slower transition. Any other questions? Okay, thanks for your attention.